Hi children, welcome all the grade 10 students to today my lessons. Right, today my lesson is unit 11 of the grade 10. Unit 11 of the grade 10. Right, what is the unit 11 of the grade 10? The unit 11 of the grade 10 is turn-in effect of a force. Turn-in effect of a force. Right, under this topic you will be able to learn about the main two topic. Right, what are the main two topic you have to learn under this topic? Right, the first one is moment, if not moment of force. The second one is couple of force. Right, after end of this lesson you will be able to know what is the moment of force and what is the couple of force. Right, so let's go to learn about the first part of the lesson, the moment, if not moment of force. Right, moment, what is the moment? Right, the moment mean production of the force and perpendicular distance. The moment mean the product of the force and the perpendicular distance. Product of the force and the perpendicular distance to the line of action of the force. Line of action of the force from the axis of rotation is known as the momentum of force around the axis. Right, now we have learned about what is the moment. No, the moment mean the product of the force and the perpendicular distance to the line of action of the force from the axis of rotation is known as the momentum of the force around the axis. Right, now think about this one. There is a object like that. Right, now think about that. Simply I will explain. Right, this object can be turned here, can be turned from here. It means this is the pivot point. This is the pivot point. Right, okay, and also some force is applied from here to turn this object into this side, to turn this object. Right, like that force should be applied, here, and also this is the place of the force applied, this is the place of the turning, if not pivot place, and also there is a distance between the pivot point and the applied force. There is a distance. Right, this distance is perpendicular to the force. No, this distance is perpendicular to the force. So moment means the product of this force and this distance. This is the momentum. Right, now simply we have learnt about what is mean by momentum. No, now simply we have learnt about what is mean by momentum. Momentum means the product of the force and the perpendicular distance to the line of action of the force from the axis of rotation is known as the moment of the force around the axis. Right, now we have learnt about the moment. Right, then we will go to look at some example. Right, now think about this picture. Right, to turn this instrument, the force should be applied. And also this is the rotation plate. Right, okay, due to this force this object is turned into this side. This is symbol is drawn. This force is turned into this side. No, this object is turned into this side. So there is a distance between the place of the force applied and phase of its rotation, if not pivot point. The product of this force and this distance is the moment. The product of this force and this distance is the moment. Right, again we will go to look at another picture. Now think about this picture. Now when we consider about this picture, this object is turned here. No, turn here. Right, this is the force applied, and also the product of the force applied here and the perpendicular distance to the from this place to this place is known as moment. Right now we have learned about what is mean by moment. No, in this picture also you will be able to help the get some idea about the moment. This is the pivot point. This is the force applied. This object turning due to application of this force, no, right? And also there is a distance between the pivot point and the force. The product of this force and this distance is known as the moment. Right now you have learned about what is mean by moment. Right? Then we will go to learn about the equation of moment. Right? We already have learned about equation of moment, no, right? Again I will explain what is the equation of moment. Right now think about, there is a object like that, right? This is the pivot point, right? And also force is applied here. There is a distance between the pivot point to the force, if not application of the force. This is the perpendicular distance. So moment means force times perpendicular distance. Force times perpendicular distance. This is the equation of the moment, perpendicular distance. Right now think about, moment is I take as the capital M. So force is F and perpendicular distance is D. So momentum simply can be written as like that equation. This is the equation of the momentum. Right now we have learned about what is mean by moment, and then we have learned about equation of moment, right? Then we will go to learn about the units of the moment, right? To take the units of the moment we have to get equation. We can use the equation to get the units of the moment, right? Equation of the moment can be written as like that. Moment is equal F times D. F means force, D means perpendicular distance, no, right? Force is normally measured in newtons. The units of the force is Newton. So the unit of the distance may be different, no, centimeter, millimeter, meter, kilometer, like that, right? Here applied SI unit. If the force is measured in, if the SI unit of the force is Newton, the SI unit of the distance is meter. So SI unit of, if not unit of moment is Newton meter. Unit of moment is Newton meter. Right now we have got the unit for the moment, no, unit for the moment is Newton per meter. Right now we have learned about what is mean by moment. After that we have learned about equation of the moment, and then we have learned about units of the moment, right? Then we will go to learn about the different types of moment, if not types of moment, right? It is taken as to teach easy, right? Now think about, now when we consider about the moment according to the direction of the turning, moment can be divided into the two groups. Right? The next one, the one of them is clockwise moment. Clockwise moment. What is the clockwise moment? One of them is clockwise moment. Right? Another one is anti-clockwise moment. anticlockwise moment. Right, what is the clockwise moment and what is the anticlockwise moment? Right, clockwise moments mean like that moments. Right, if the force is applied here, if force is applied from some distance, no, this is the pivot point, this is the pivot point, there is a distance here, this is the pivot point. Right, due to this momentum, this object is turned into this side, this object is turned into this side. Right, it is the direction of the turn in the direction of the clock, no, therefore like that moment is known as clockwise momentum. And also now think about this one. Right, if the force is applied this side, this is the pivot point, force is applied this side, F, and distance is d, distance is d. Right, here due to this moment, this object is turned into anticlockwise, therefore this moment is known as anticlockwise moment, this moment is known as clockwise moment. Right, now we have learned about the types of the moment, no, now we have learned about the types of moment. Under the types of moment we have learned about clockwise moment and anti-clockwise moment. Right, again we will go to learn about what is the clockwise moment and what are the examples for the clockwise moment. Clockwise moment mean, again I will explain, clockwise moment mean like that moments, no, like that moments is known as clockwise moment. Clockwise moment, there is a distance between here, due to this moment of force this object is turned into clockwise direction, therefore this types of the momentum is known as clockwise moment. Right, next one. Now there is a question we have to solve. There is 0.5 meter from the pivot point to the application of the force. The force applied is the 5 Newton. Right, how to calculate the clockwise moment here? Right, for this we can use our equation. Our equation is momentum is equal F times d, no, momentum is equal F times d, right. Force is 5 Newton, right, 5 Newton times 0.5 meter, then what will happen? 5 times 5, 25, no, 25, but there is a 1 decimal place, so decimal place should be put here. Unit is Newton meter. We already know the unit of the moment, no, the unit of the moment is Newton meter. So now we know how to calculate the moment of force. Right, then we will go to our next question. Next question is distance is 0.5 meter, the force applied is 10 meter. Right, how to calculate the momentum? Momentum calculated by using F times d. Right, here the F is 10 Newton. The distance is 0.5 meter. So how to calculate? 10 times 5 is 5, no, 5. Unit is Newton meter. Right, now we know how to calculate the momentum. This is the clockwise moment, no, because this object is turned into the clockwise direction, therefore this types of momentum is known as clockwise. Right, then we will go to learn about the anti-clockwise moment. We already have learnt about what is the anti-clockwise moment. Right, doesn't matter, again I will explain what is the anti-clockwise moment. Now think about, there is a pivot place. Right, F force is applied into this direction. Right, and also there is a perpendicular distance between the force applied point and the pivot point. Right, due to this moment this object is turned into this side, These types of moment is known as anticlockwise moment. Anticlockwise moment. Right now we have learned about what is the moment, and then we have learned about the equation of the moment. After that we have learned about the units of the moment. After that we have learned about the types of moment. Under the types of moment we have learned about there are two types of moment. One of them is clockwise moment and another one is anticlockwise moment. Anticlockwise moment, right? Then we will go to solve some question related to the anticlockwise moment. Now look at this picture, right? 4 Newton force is applied in this side, right? And also there is a perpendicular distance 0.4 meter from force apply point to the pivot point, right? Due to this moment, there is a moment created, no, right? Due to this moment, this object is turned into this direction. It means anti-clockwise direction. So let's go to how to calculate the moment of force here. Moment of force can be, if not moment can be calculated by F times D. No, we already have learned about the equation of the moment, right? Force, F means force is the 4 Newton. So 4 Newton can be applied to here, right? D is the perpendicular distances. Here the perpendicular distance is 0.4 meter. Therefore it also can be substituted here, 0.4 meter, right? We know 4 times 4 is 16, no? 16, but there is a one decimal place, so we have to put one decimal place here. So 1.6 unit is Newton meter. Unit is Newton meter. Right now we have got the answer for this question, right? Then we will go to our next part. Equilibrium of an object under the moment of force. Equilibrium of an object under the moment of force. Now think about like that diagram. Now there is an object like that. Now there is an object like that, right? This object is kept on the like that knife edge, and also there is a force here. There is a perpendicular force here. I will name this one is F1, and also the distance between the pivot point to the force applied is D1. Now think about D1, right? And also now here created the moment of force. No, due to this moment of force, this object turn into this side. The turn-in can be prevented by applying the force from this side. No, therefore now think about to prevent, if not to equilibrium, F2 force is exerted here, and also there is a distance D2 from pivot point to the application of the force, right? And also for equilibrium, due to this momentum, this object turns into this side, no, right? For equilibrium, this momentum should be equal to this momentum is mean clockwise moment. Here the anti-clockwise moment. For equilibrium, anti-clockwise moment should be equal to clockwise moment. Anti-clockwise moment should be equal to clockwise moment, right? Now what is the anti-clockwise moment? Anti-clockwise moment mean F1 times D1, no? F1 times D1. Clockwise moment F2 times D2, right? For equilibrium, the clockwise moment, if not anti-clockwise moment, should be equal to the clockwise moment. Here the anti-clockwise moment is F1 times D1. Here the clockwise moment is F2 times d2. Right now we have learnt about how to get the equation of the equilibrium of an object under the moment of force, right? Then we will go to our next one, right? Then we have to use question. Now look at here, right? F force is applied here from the 0.25 meter, right? Here the 5 Newton is applied from the 0.5 Newton meter. For the equilibrium, this anti-clockwise momentum should be equal to this clockwise momentum. No, so this one can be written as, if not can be, if we have to found, no, right, can you get the value of the F by using this equation, right? Now think about F1 d1 is equal F2 d2. We already have learned about this equation, no? Right? F1 is F. We don't know value of the F. We have to get the value of this one. d1 is 0.25 meter. F2 is 5 Newton. d2 is 0.5 meter, no? Right, then F, to get the F, 0.25 should be removed. For this side should be divided by 0.25 meter. If this side divided by 0.25 meter, this side also should be divided by 0.25 meter, right? After that what will happen? 0.2 times 1, 0.2 times can be cancelled. F is remaining, no? Here meter can be cancelled. 0.2 times 1, 0.2 times 2. Then remaining 5 Newton times 2. Meter can be cancelled, no? Right, 5 Newton times 2 means 10 Newton. So answer for this question is 10 Newton. Right now we know how to calculate the sum, if not force or distance, by using equilibrium of the force under the moment of force, right? Then we will go to our next part, right? And also there is another question. We have to get the force, no? Here, due to this moment, this object is turned into this direction, anti-clockwise direction. Due to this moment, this object turns into clockwise direction, right? We have to calculate the force. So this F1 d1 is equal F2 d2, right? F1 is 120 Newton times 6 meter. F2 is F. Distance is 8 meter. Then both sides should be divided by 8 meter, no? Both sides should be divided by 8 meter. After that what will happen? 8 meter can be cancelled. Here F is remaining. Then what will happen? Meter can be cancelled. Then 8 times 1. 8 times 1. No. Then 4 is remaining. 40 divided by 8 means 5. Therefore remaining 15 Newton times 6 meter. Sorry, 6. Therefore F 6 times 33 is remaining then 90. So 90 Newton is the required for the equilibrium of this object, right? Then we will go to our next one, right? Our next one is factors affecting for the moment. Right now we have learned about what is the moment. After that we have learned about the equation of the moments. After that we have learned about the units of the moment. and then types of the moment. Under the types of the moment, we have learnt about clockwise moment and anti-clockwise moment and equilibrium of and under the object due to moment of force. Right now we are going to learn about the factors affecting for the moment. What are the factors affecting for the moment? There are two factors affect for the moment of force. There are two factors affect for the moment of force, right? One of them is magnitude of the force. Magnitude of the force. The second one is distance between force and the pivot point. The distance between the force and the pivot point, those things we have learned about under the equation of the moment. Now right, then we will go to learn about our next topic. Our next topic is investigation of the dependence of the moment on the magnitude of the force. For this you can do this experiment, if not do this activity. Now think about, there is a screw nail here, table surface, if not or flank of the wood, calibrated strips of wood, right? Now think about, this object can be turned clockwise or anti-clockwise by applying force, no? By applying force, right? Now when we consider about now think about, there is a fixed moment of force to turn this one. There is a fixed moment to turn this object. When this object is to turn when force is applied from the place of A. Now think about, the magnitude of the force should be high, no? The magnitude of the force should be high, right? And also when we applied the force from the B, this applied force should be reduced. Now think about like that, to turn this object from the A, we will use F1 force. F1 force right here. If we force applied here, F2. When we applied from the F3 here, C place, F3, right here, this one, F4. Then what will happen? When when force applied place is go away from the pivot point, the force should be reduced. The force should be reduced, no? Automatically reduced, because when distance is increased, force is decreased, because the moment means the product of the force and distance, no? Moment means force times distance. Force times distance, right? When distance is increased, force should be decreased. Therefore F1 force is the highest force here. F2 is less than the F1. F3 is less than the F2. F4 is less than the F3. Like that. The minimum force should be applied to the place D to turn this object, right? In this experiment we can conclude that dependence of the magnitude of the, if not moment, on the magnitude of the force. In this experiment can conclude that the magnitude of the force is effect for the moment of the force. Moment of the force, right? Then we will go to our next point. When force is increased, moment of force is also increased. When force is increased, moment of force is also increased, right? The next one, investigation of the dependence of the moment on the perpendicular distance to the force from the point of suspension, right? For this, now again think about like that one, right? Here the force, F1 force is applied from the x1 distance from pivot point, no? F1 here should be F2. We will correct this F2. F2 force is applied from the direction of the x2. Then what will happen? Here the momentum is F1 time x1, no? Here the momentum is F2 times x2, right? Then now think about, x2 is greater than x2 is greater than x1, no? Therefore, what will happen? The force, it opposite, no? F1 is greater than F2. Right? What is the conclusion of this activity? The conclusion of the activity is when the distance is increased, for the force applied should be decreased. The force applied should be decreased. It means the distance, if not perpendicular distance, also affect for the moment of the force. The perpendicular distance also affect for the moment of the force, right? Then we will go to our next point. When increase the perpendicular distance, moment of a force. Right now we have learnt about the moment of force. Right now we are going to learn about the another part of the lesson. The another part of this lesson is couple of force. Right now think about what is the couple of force. Couple of force mean the two coplanar forces of equal magnitudes and in opposite direction along two lines of action that are spaced apart are known as couple of force. Right now we have learned about what is meant by couple of force, no? Right, you will be able to clear that, if not clear the what is the couple of force, by observing this diagram. Now think about, there is a line, no? This object is rotated from here. It means this is the pivot point, right? Here a force is applied, right? Due to this force, clockwise moment is created, no? Clockwise moment is created, and also same force to this force is applied from this here, right? And also there is a force and perpendicular distance here. Due to this moment of force, this object is turned into here, right? Therefore this moment and this moment, it act on the same direction. The both moment are the clockwise, no? Both moment are the clockwise. Therefore this phenomenon is known as couple of force. This couple of force can be calculated by one force multiples by the distance between the two points, right? Then we will go to get the equation for this couple of force. Before learn about the couple of force, we will go to learn about what are the occasion that couple of force is applied. Now think about a water tap. To close or open this water tap should be applied. Different force is applied like that, no? Here the F in the opposite direction. There is a distance between the two force. Here also act on the couple of force. Now think about steering wheel of the vehicle. To turn the steering wheel, this object is turned into like that upper side, right? And also there is a distance between same momentum act on the one direction at the two place, right? Next diagram. Here also force is applied downward, upward. Those are the occasions that the couple of force is created, right? Then we will go to get the equation for the couple of force. Now think about, there is object like that, right, like that. One force is applied here. Here the F force. This is the pivot point. The distance between two points is D. Therefore here is the distance is the D divided by 2. Here also D divided by 2, no? D divided by 2. Then couple of means this is the clockwise moment. This is also clockwise mean, no? Clockwise moment. Then couple of force mean the sum of these one, no? Here the applied moment is F times D divided by 2. Another moment of force is F times D divided by 2. Here the F is common factor, no? Therefore other things is D divided by 2 plus d divided by 2. Then what will happen? F times, here the 2d divided by 2. Then 2 times 2 can be cancelled, remaining F times d, F times d the couple of force. F times d the couple of force. It means one force times the distance between two force is the couple of force. Right now we have learnt about what is the couple of force. What is the couple of force, right? Then we have to learn about what are the exercise of the lesson, right? Under this topic today we have learned about the couple of force and moment of force and couple of force, right? In my next video I will explain some question related to the turning effect of the force, if not moment of force and couple of force, right? Have a nice day for all.